In this video, we are going to work on different ways to use substitution to solve the integral of square root functions. It has many types, and this is the first type when the expression under the square root is a linear function. You can see the expression under the square root is a linear function. And again, it has further two subcategories. First one is when there is nothing outside the square root function, or there may be a constant outside the square root function. And the second subcategory is when there is a variable x outside the square root function. We always assume the expression under the square root as u. So let us assume this expression, this linear function, as u. Then we take the derivative of both the sides. The derivative of u is du, derivative of 2x is 2 dx, and the derivative of constant 1 is 0. But here we are given only dx. So we need to isolate dx here. For that, we divide both sides by 2 and get the expression for dx. This was step 1. Then for the second step, we convert the given integral in terms of u. Square root of 2x plus 1 becomes square root of u because dx is equivalent to du over 2. So we replace dx with du over 2. Then we can move this constant outside the integral. 1 over 2 is moved outside. To get the integral of square root function, first we rewrite it in terms of exponent. So we can write it as u raised to power 1/2 du. Then we apply the power rule of integration, which is just opposite to the power rule of differentiation. While taking derivative, the power get reduced by 1. But for the antiderivatives, the power get increased by 1. At last, you put an integration constant c, then we simplify it further, u raised to power 3/2. Then this 3 over 2 get flipped and written as multiplication with 1/2. At last, we plug in back u in terms of x. U was 2x plus 1, so we replace u with 2x plus 1. This is the answer for the integral. For this type of integrals, there is a variable present outside the square root. First, we assume u as the expression under the square root. So u equals 2x plus 1. The derivative of both sides, we get the same thing as we did earlier. This was step 1. Now there is another part of step 1. We got the expression 2x plus 1 written in terms of u. But what to do with this x present outside? This also need to be written in terms of u. So using this u substitution, we solve this equation for x. Subtract 1 from both sides. So we get x in terms of u. We can replace x as u minus 1 over 2. For next step, we are going to rewrite the given expression in terms of u. X can be replaced with u minus 1 over 2. Square root part can be written as square root of u. Dx can be replaced with du over. We simplify it further. This constant 2 and 2 get outside. So we get 1 over 4 outside the integral. We are going to simplify it further. It becomes u times square root u minus square root u du. And then we are going to rewrite this expression using exponents. U raised to 1 and u raised to 1/2. U raised to 1 and u raised to 1/2 gives you u raised to 1 plus 1 over 2 becomes u raised to 3/2 minus u raised to 1/2. And then we apply the power rule of integration for each term separately. So the power 3/2 get increased by 1, and here the power 1/2 get increased by 1. At last, the integration constant c. We keep on simplifying it further. Denominators get flipped as 2 over 5 times u raised to 5 over 2 minus 2/3. And at last, don't forget to plug in back u, because the final answer should be in terms of x. U was 2x plus 1, so we plug in back u as 2x plus 1. This is the answer for this integration problem. And here is the next type of square root problems, when the expression under the square root is no more a linear function. It's a non-linear function now. And when there is a non-linear function under the square root, there must be the derivative of this function around. The derivative of x cube plus 1 is 3x square, and it's given along with. We are going to use the u substitution for this. We always assume the expression under the square root as u. We are going to use u equals x cube plus 1. then take the derivative of both sides. This was step 1. For such type of problems, it's better to write the square root first and then we write 3x square and dx together. And now it's easy to rewrite it in terms of u. X cube plus 1 is u, so it's square root of u times 3x square dx can be replaced with du. It's a simple integral now. We solve it using the power rule and at last we plug in back u as x cube plus 1 and this is the final answer. For this problem, again we substitute the expression under the square root as u and then take the derivative of both sides. Here the first step was same as the earlier one. We just isolated x square dx here as du over 3 and now we are going to rewrite the given integral in terms of u. This top expression x square dx is replaced with du over 3 and the denominator is square root of u. Then this constant in the denominator is taken out and the square root is rewritten as power, which is taken to the top as negative half, and then apply the power rule of integration and then this 1/2 get flipped and it becomes 2 over 1. Power 1/2 is written as square root. At last we plug in back u to get the final answer. So this is how we use u substitution for different types of square root functions.